Hello students, welcome to Sri Joyendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 4 of our unit Oscillations. So let's begin with today's class. In today's class, we are going to discuss the graphical representation of displacement, velocity and acceleration in SHM, simple harmonic motion. So let's have a look. When we say that a particle has started its position, its motion from the mean position, the general expression for the displacement in SHM that could be given as that x is equals to a sine omega t plus alpha, that we know. And let's suppose if I understood and if we consider that alpha is equals to 0, then this displacement could be given as x, which is equals to a sine omega t, and from this it's a v which is equals to dx by dt. If this v is equals to dx by dt, this is equals to d by dt of sine omega t, which is what we know as the a omega cos omega t. If I differentiate it one more time, then this is equals to a is equals to dv by dt, and that is equals to minus of a omega square sine omega t. So let's suppose we have the relation of the x is equals to a sine omega t. It is simply something like this. It's a sine omega t, and this omega could be represented as you have seen it here. It's a 2 pi by t into t. So if I put omega into t, which is equals to 2 pi by t into t, which is the phase, then at different times let's see what value we are going to receive. So if I put at t is equals to 0, we are just putting the value in the omega t, then this is equals to 2 pi by t into 0. So at t is equals to 0, omega t would be a 0. At t is equals to t pi by 4, it's a 2 pi by t into t by 4. This t has gone, and this is 2 pi by 5, it's a pi by 2. When t is equals to t by 2, the situation will be omega t, that is equals to 2 pi by t into t by 2. This t has gone, and this is 2 pi by 2, this is equals to pi. When t is equals to, when this time t is equals to 3t by 4, then it is omega t is equals to 2 pi by t into 3t by 4. This t has gone, and even this has gone, so this is 3 into pi by 2, this is 3 pi by 2. And when this small t is equals to capital T, this is omega t, that means it's a 2 pi by t into t, and this t has gone, and this is equals to 2 pi. So in this situation, if t is equals to 0, phase is 0, t is equals to t by 4, it's a pi by 2, t by 2, it's a pi, 3t by 4, it's a 3 pi by 2, and at t that is equals to 2 pi. This is the situation. Now if I put this values, into the displacement relation, that relation is given as that x is equals to a sine omega t, and omega is equals to 2 pi by t. And when t is equals to 0, then the situation will be x equals to a sine 2 pi by t into 0. It's a sine 0 degree, and as we know that sine 0 degree will be equals to 0. So it's anything multiplied by 0 multiplied by a would be the 0. So initially at t is equals to 0, your displacement would be a 0. And we are going to do the same thing with every time, that is the x is equals to a sine omega t. Omega is equals to 2 pi by t. Now when t is equals to t by 4, I'm going to put this value into this relation. It's a 2 pi by t multiplied by t by 4. This t and this t has cancelled, and it's a 2 pi by 4. So this has been, I have been left with the x is equals to a sine pi by 2, and sine pi by 2, it's a sine of 90 degree, and when it's a sine 90 degree, it is equals to 1. So this is 1 multiplied by a, which is equals to a. Same way, if it was the case of x is equals to a sine omega t and time is the t by 2, so this is equals to omega, that is equals to 2 pi by t. This is a sine 2 pi by t into t by 2. This t and t has gone, this 2 has gone, this is, I have been left with the sine pi. And when it is a sine pi, this is sine 180 degree. This sine 180 degree will be the 0. So this is equals to x equals to 0. Next, it is the time of 3t by 4, and if I put up the value, it's an x equals to a sine 2 pi by t into 3t by 4. This t and t has gone, this 2 and 4 has gone, so I have been left with the 3 pi by 2. This is equals to sine of 3 pi by 2, which is equals to 270 degree, and this sine 270 is minus 1, and this minus 1 multiplied by a, this is equals to minus of a. Yes. Next, it is the time when t is equals to t. So this is equals to x equals to a sine omega t, and from this it's an omega which is equals to 2 pi by t into t. This t and t has been cancelled out. It's a sine 2 pi, and sine 2 pi will be the 0. So it's a 0 multiplied by a would be equals to 0. I hope this is clear. So if I summarize this, all the data, then this is the time and this is the phase and this is the displacement. At t is equals to 0, phase is 0, displacement is 0. At t is equals to t by 4, it is phase would be the pi by 2, while displacement is a. At t is equals to t by 2, phase was the pi and displacement is 0. And such as the, if time is the 3t by 4, phase would be the 3 pi by 2 and the displacement would be minus a. Same way, when time is capital T, it's a total time, or we should say it's a complete time period of one oscillation, then phase would be a 2 pi and displacement would be a 0. So if I'm going to plot this displacement versus time, then it would be the situation that on the y-axis I have plot the displacement, let's denote it by x, and on the x-axis I have denoted the time. So at t is equals to 0, it has started its motion from 0, so it is 0 over here. At t is equals to t by 4, it reaches to the maximum amplitude that has been represented over here. At t is equals to t by 2, it's in half of the time period, it is at the 0. At t is equals to 3t by 4, it is at a minus of a, so this would be the situation. And this at t is equals to t, it is at the 0 displacement. I hope this is clear. Is it clear? So this is how the displacement graph for the SHM is seen. I hope this is clear. So now we are going to represent the velocity in the same situation. So if it was the case that x is equals to a sine omega t, if I differentiate this is v is equals to dx by dt. I am going to have this. It's a v is equals to a omega cos omega t, and this omega could be represented as omega is equals to 2 pi by t. And let's say when t is equals to 0, then this v is equals to a omega cos 2 pi by t into 0. And when this is 0, when this is cos of 0 degree, this is equals to v, which is equals to a into a omega. Same way, let's calculate it for the t is equals to t by 4. So this is a omega cos 2 pi by t into t by 4. This t gone, this 2 4, that's a pi by 2, and this is cos 90 degree, it's a pi by 2. Cos 90 degree would be a 0, so this velocity would be a 0. Next is the situation when time is t by 2. So this is equals to v is equals to a omega cos 2 pi by t into t by 2. This t gone, this 2 pi by 2, this has gone, and I have been left with the cos pi. When it is the case of the cos pi, this cos pi tends to a minus of 1, and if it is a minus of 1, this is equals to minus of a omega. Yes. Next is the time when t is equals to 3t by 4. So if I put this, it's a 2 pi by t multiplied by 3t by 4. So this t and t, that is over, and this is 2 pi by 4, it's a 2 it's a 3 pi by 2 left. So it's a cos of 270 degree, and cos 270 degree is a 0. So 0 multiplied by any number would convert to the 0, and this at this point velocity would be 0. From this, at last instant, it's a t is equals to capital T. So this is equals to this t, and this t has been over, and I have been left with the cos 2 pi, and cos 2 pi it is same as the cos of 0 degree, which will give me the 1. So this is V is equals to A omega. I hope this is clear. So if I summarized it and that the same table, then this is V is equals to A omega cos omega t, and I have already written all the previous values as well, so that we can have a comparison that at t is equals to 0 velocity would be the maximum, it's an A omega. At t by 4 velocity 0, t by 2 minus of A omega, 3t by 4 again 0, and capital T it's an A omega. I hope this is clear. Is it clear? So do you understand what we are supposed to do? Basically what we are doing at this present is that we are just preparing a table, so that we can plot the relations on the graph of the displacement versus time, or let's say velocity versus time, or let's say acceleration versus time. Yes, so we are in a first phase, we are in a phase of preparing a table, so that this can help us. I hope this is clear. Great. Now let's understood that how the acceleration table will be there. So we are just accumulating a data. First at t is equals to 0. This is a, which is equals to minus of a omega square sine omega t, and this a is equals to 2 pi by t into 0. It's again sine 0 degree, and sine 0 would be a 0. So at this instant, at the time t is equals to 0, at the beginning of the motion, acceleration is 0, and if acceleration is 0, same way force is 0. Let's say this, it's an a which is equals to minus of a omega square sine omega t, and it is at t is equals to t pi by 4, and omega is equals to 2 pi by t. If this is the case, then this is 2 pi by t into t by 4. If I am going to solve this, this is sine pi by 2, which is sine 90 degree, and if this is sine pi by 2 or sine 90 degree, then sine 90 will be the 1, and if it is sine 90 which is equals to 1, this is equals to a is equals to minus of a omega square. Next, it's an a is equals to minus of a omega square sine omega t, and I'm going calculating this for the t by 2. So let's put up the value. It's an omega, it is equals to 2 pi by t, multiplied by this term, it is t by 2. This gone, this gone, and I have been left with the sine pi. It's a sine 180 degree. Sine 180 degree, it's a 0. So this acceleration value would be a 0. Same way, let's calculate it for the 3t by 4. So if I replace the value, it's a 2 pi by t into 3t by 4. T has gone, 2, 4 has gone, so this is equals to sine 3 pi by 2, and sine 3 pi by 2, it's a 1. So it's an a which is equals to a omega square. Next, it's an for the time period of t. So it's an omega is equals to 2 pi by t, and that would be equals to a is equals to 2 pi by t into t. This and this has cancelled, so this is equals to minus of a omega square into sine of 2 pi, and sine 2 pi, it's a 0. So this is the acceleration which is equals to 0. So let's even summarize all these things, that this is the phase, this is the phase, and this is the displacement, this is the velocity, this is the acceleration for every different time. It's a time what we have taken as a reference is 0, 0, t by 4, t by 2, 3t by 4, and t. So at t is equals to 0, at t is equals to t by 4, and every time they have given the situation. I hope this is clear. Is it clear? Is it? Do you understand this? Do you understand this? Great. Now one more thing that you might have noticed is that x was the a sine omega t, v is the a omega cos omega t. So if, as in the previous lecture, we used to discuss the time period and phase of an SHM, we have go through this, that if I want to find out the phase difference between this two, I need to convert either of this. I need to convert either of this into the same function. So let's convert this. It's an a omega sine omega t plus pi by 2. Same way my acceleration was, it was minus of a omega square sine omega t. From this, this could be given as this is equals to minus of a omega square into sine omega t, or if I want to this as a plus, plus pi. Yes, because it's a minus over here. So now I can compare the phase of this two, and if you compare this, look at this, this is x equals to a sine omega t, while this v is then omega t plus pi by 2. So that means displacement and velocity having a phase difference of pi by 2 between displacement and velocity. If you observe the velocity and acceleration, this is pi by 2, which is 90 degree, this is pi, this is 180 degree. So again, between velocity and acceleration there is a there is a phase difference of pi by 2. In the same way, if I want the phase difference between displacement x and acceleration a, this is just omega t, this is omega t plus pi. So there is a phase difference. There is a phase difference between this two. It's a displacement and acceleration is of 180 degree. This is the phase difference of this. So please do remember this. Displacement and velocity, they are having a phase difference of pi by 2, 90 degree. Velocity and acceleration, they are having a phase difference of again pi by 2. And displacement and acceleration, they are having a phase difference of pi. Please keep this noted. Please do noted it. Yes, this will help us. So do you understand everything up till now? Have you understood this? Are you sure? Do you have any doubts? Is there anything? Is there? Are you sure? Let's look at certain quick questions. So the question is, there is a phase difference of blank between velocity and acceleration. Yes, velocity and acceleration are pi by 2 di difference. There is a phase difference of pi by 2 between velocity and acceleration. All curves represent same path after the phase of, yes, they are going to have a same path after 2 pi radian, because it's a time period of all the curves. I hope this is clear. So if I make a summary, that phase difference between displacement and velocity is pi by 2. A phase difference between velocity and acceleration is pi by 2. And next is the phase difference between displacement and acceleration is pi. It's a 180 degree. I hope this is clear. So please keep this in mind. There is a phase difference of pi by 2 between velocity and displacement, and velocity and acceleration again phase difference of pi by 2, and displacement and acceleration phase difference of pi. Great. So now let's understand the graphical representation when particle has started from the mean position, a part 2. So this was our table when what we have derived from the relation which was equals to x equals to a sine omega t, and what we have done is that a sine, this is 2 pi by t multiplied by small t. This small t we have replaced this by this different times, and for that whatever the data we have achieved is written on this table. Yes, as you are aware with this. So now let's try to plot this function. As I have said it, that we are trying to plot these functions. Let's look at them one by one. This is the relation. This is the graph for the displacement versus time. And when I say it's a displacement versus time, this is the t is equals to 0, displacement is 0. So they have started it from here. At t is equals to t by 4, displacement is e. This is maximum displacement plus a that we have written over here. Displacement t is displacement when time is t by 2, it's a 0. So again at t by 2 you should be at 0. At 3t by 4, at 3t by 4 this is minus a, it is at here. And at t it is at 0, so you have been reached at here. I hope this is clear. So this is the representation of displacement versus time. Same way, let's look at the representation of velocity with respect to time. So for when you plot the velocity, this is the time at t is equals to 0. Your velocity is maximum possible, which is equals to a omega. This is a omega. At t is equals to t by 4. At t is equals to t by 4, your velocity would be a 0. It is here. At t is equals to t by 2, it is a minus of a omega. It is here. At t is equals to 3t by 4, at t is equals to 3t by 4, this velocity would be a 0. It is at here. And at t is equals to t, at t is equals to t, it is at a omega. It is here. Yes. So this is basically a cosine graph. Basically when we plot this v, it was v is equals to a omega cos omega t. So you should remember that this is the graph of the cos, and now you understand that this is a graph of the sine, which is x is equals to a sine omega t. And when you look at this two graphs, you can identify the difference between these two. Even I will see you the next in next slides the all three graphs together so that you can compare them easily. But before we go through this comparison, let's first represent the acceleration. Let's first represent the acceleration and time graph. So this is acceleration, which is equals to a omega square, and this is time t. So from this, at t is equals to 0, acceleration is 0. It is here. At t is equals to t by 4, this is minus of a omega square, so it is at here. At t is equals to t by 2, acceleration is 0. At 3t by 4, this is equals to plus a omega square. And at t is equals to t, this is here. I hope this is clear. So do you understand this? This is the graph of the acceleration versus time. I hope this is clear. Now let's look at this very carefully, and you might understand that this is the displacement. The function of displacement is the x equals to a sine omega t. The function of this velocity graph was a omega cos omega t, and the function of this, it's an a is equals to minus of a omega square sine omega t. This is the function of the acceleration. So basically the situation is, this is the graph of the sine. When you have been given a sine function, its graph will look like this. Yes, it is the function having amplitude a, so that's why this distance we have denoted as a. This is the graph of the cos. Basically this represents the cos, and this is equals to v is equals to a omega cos omega t. I hope this is clear. One more very interesting aspect of these two graphs is that when you plot sine and cos, please keep this in mind that when sine is minimum, cos is maximum. When sine is maximum, cos is minimum. When sine is minimum, again cos is maximum. When sine is maximum, again cos is 0. So they become maximum and minimum alternatingly. I hope this is clear. Yes, great. Now let's suppose again this acceleration graph, it is again a graph of the sine itself, but we are having a minus over here. I hope you understand this. We are having a minus over here, and when I have represented it with minus, that means this graph will be just a mirror replica of this. Yes, if you forget the amplitude, because amplitude is the value that denote value of that only. But if you look at this according to the graphics, then this graph is just the mirror replica, or I should say you just multiply this x equals to a sine omega t or sine omega t with minus 1, and you will have the graph of the acceleration. I hope this is clear. So do you understand completely? Have you got this? Are you sure? Do you understand? One more thing. From here to you can look that there is a phase difference of pi by 2 between this two. Yes, phase difference of pi by 2 between velocity and displacement. Phase difference of pi by 2 between this two, it's a velocity and acceleration, and it is the phase difference of pi between this two, between the displacement and acceleration. So have you got this? Have you got this completely? Do you have any doubts up till now? Is there anything? Is there anything? Is there? Is there? No? So let's conclude it again one more time so that that can be remembered and that cannot be forget. There is a phase difference of pi by 2 radian between displacement and velocity. A phase difference of pi by 2 radian between velocity and acceleration. And there is a phase difference between pi radian between the displacement and acceleration. I hope this is clear and you are not going to forget this. Yes? Great. Now, whatever we have discussed was the motion when particle started its motion from the mean position. Now we are going to discuss the graphical representation of the extreme position. That means if my particle has started its motion from the extreme position, what would be the situation? Let's have a look. So when it has started its motion that could be written as x equals to a cos omega t, that we learn in the very first lecture, that if my particle has started its motion from the mean position, I am going to write it as x is equals to a sine omega t. And if my particle has started its motion from the extreme position, I am going to write it as an x equals to a cos omega t. I am going to replace this omega with 2 pi by t, and when I put it's a t is equals to 0, this is equals to x equals to a cos 2 pi by t into 0. This is cos of 0 degree. When it's a cos of 0 degree, it's a 1, so it's an a cos 0 degree. Cos 0 is 1, so this is equals to x equals to a. Next time it's a t is equals to t by 4. So if I put this omega in equals to 2 pi by t and small t, that's the t by 4. So this is 2 pi by t into t by 4. This t has gone. This is 2 pi by 4. This is equals to pi by 2. And this cos pi by 2, this will be the 0. Next, it's an x is equals to a cos omega t. And from this, it's an omega which is equals to 2 pi by t. And from this, it's a t. Capital T is equals to t by 2. So if it is a capital T is equals to t by 2, this is equals to a cos 2 pi by t into t by 2. This t cancelled out. And this is 2 pi by 2. This 2 and 2 has gone. And this is cos pi. So when this is cos pi, when this is equals to cos pi would be the minus of 1. Minus of 1 into a, it's a x equals to minus of a. Next time it's a t is equals to 3t by 4. If I put up the value, it's a 2 pi by t multiplied by 3t by 4. This t gone, this 2's are 4, and I have been left with the cos of 3 pi by 2, which is cos 270 degree, which is 0. Sorry, not 0 degree, it's a 0. So this will give me an x, this will give me an x equals to 0. Next, it's an x equals to a cos omega t. This omega, it is equals to 2 pi by t, and when this is the situation, when t is equals to t, this is x equals to a cos 2 pi by capital T into small t. So this t has gone, and I have been left with the cos 2 pi, and cos 2 pi, it's a cos 0 degree, so this will be the a. So this displacement is a. Let's summarize it on the table, that this was the displacement relations. which was x equals to a cos omega t. And from this I have that at time t is equals to 0, displacement is a. At t by 4 this is 0. At t by 2 this is minus of a. At 3t by 4 it's a 0, and at t it's equals to a. Now this was about the displacement. Now we are going to plot, and we are going to first make a table for the velocity. So if x is equals to a cos omega t, I'm going to have this v by differentiating it with respect to time. That is v is equals to dx by dt, and when I write it's a v is equals to dx by dt, this is equals to minus of a omega sine omega t. If such is the situation, then omega is equals to 2 pi by t. And let's say when t is equals to 0, when t is equals to 0, this is v is equals to minus of a omega sine 2 pi by t into 0, and this is sine 0 degree. If it is a sine 0 degree, its velocity would be 0 when at t is equals to 0. Let's calculate it for the next instance, which is t by 4. This is equals to minus of a omega sine 2 pi by t into t by 4, and this is minus of a omega sine pi by 2. Sine pi by 2 is 1, so velocity is equals to minus of a omega. Next is the instant when t is equals to t by 2, and if I put this, it's a 2 pi by t into t by 2. This t has gone, this 2 has gone, it's a minus of a omega sine pi. If it is minus of a omega sine pi, this sine pi is 0, and this velocity would be equals to 0. Next is the instant when this time t is equals to 3t by 4. So this will give me the minus of a omega sine 3 pi by 2, and that will be the equals to v is equals to a omega. And it is at when t is equals to capital T. If I put this, it's a sine of 2 pi, it's a 0 degree, it's a 0. So if it is a 0, it is a minus of a omega into 0, and this velocity will be the 0. If I look at the table, then it would be the time t is equals to 0, a phase would be a 0, displacement would be the maximum, velocity would be the 0. At t by 4, the displacement is 0 and velocity of minus of a omega. At t by 2, displacement is minus a and velocity is 0. At 3t by 4, this is 3 pi by 2, this is 0 and this is a omega. At t, it's a 2 pi a and 0. Yes, I hope this is clear. So this was all about the velocity. Now what is next? Yes, you assume it correctly. Now it's a time for the acceleration. So this acceleration a, which is equals to minus of a omega square into cos omega t. And if I replace this with omega, which is equals to 2 pi by t, then at t is equals to 0, when t is equals to 0, this a is equals to minus of a omega square into cos 2 pi by t into 0. This is cos 0 degree, and if it is a cos 0 degree, its acceleration would be equals to 0. Next is the instant when you need to do this for t is equals to t by 4, and this is simply minus of a omega square into cos 2 pi by t into t by 4. So this will give me a minus of a omega square into cos of pi by 2, which is cos 90 degree, and cos 90, it's a 0. So this is equals to acceleration, that is equals to 0. Next, for the instant t is equals to t by 2, this will give me a minus of a omega square cos pi. If it's a cos pi, it's a minus of 1, so it's a minus minus plus 1, which will give you the acceleration, which is equals to a omega square. Next, it's a t is equals to 3t by 4. This was the relation. It's a 2 pi by t multiplied by 3t by 4. This t has gone, this has gone. It was 3 pi by 2. This cos 3 pi by 2 would be the 0. 0 multiplied by anything, that would be the 0. Next, it's a t is equals to t. This is equals to 2 pi by t into t, and when this has gone, it's a cos 2 pi, and cos 2 pi is 1. So this is 1 minus of a omega square. This is equals to minus of a omega square. Let's summarize this, that these are the times, and these are the different parameters such as phase, displacement, velocity, and accelerations. I hope this is clear. Is it clear? Is it? So now let's just plot this. Let's just plot this. It is the graphical representation when the particle has started its motion from the extreme position. Let's have a look. First, it's a displacement. So as particle has started its motion from the extreme, it is x is equals to a cos omega t. As we have understood in the previous case as well, that this is basically the graph of the cos. This is the basically the graph of the cos, that at t is equals to 0, at t is equals to 0 you start your motion from the extreme position. So at t equals to 0, displacement is a. At t is equals to t by 4, displacement is 0. Here it is. At t is equals to t by 2, displacement is minus a. Here it is. At t is equals to 3t by 4, it is at 0. And t is equals to t, it is at a. I hope this is clear. Next is the velocity when x is equals to a cos omega t. V was minus of a omega sine omega t. As minus is written over here, that means it is simply the sine curve with multiplied by minus of 1. So at t is equals to 0, the velocity is 0. Here it is. At t is equals to t by 4, it's a minus of a omega. Here it is. At t is equals to t by 2, this is 0. Yes, at t equals to 3t by 4, it is plus a omega. And at t is equals to t, this velocity would be the 0. Now let's plot the acceleration. So the acceleration, it was minus of a omega square cos omega t. Again, this is with minus. It's a curve of cos but with minus. That's why it has started from the extreme but negative in extreme. So at t is equals to 0, minus a omega square. At t equals to t by 4, it's a 0. T by 2, it's a plus a omega square. Look at this. It started with this, then t by 4, it's a 0. T by 2, it is the plus a omega square. And at 3t by 4, it is again at 0. And at t is equals to t, it again has a minus of a omega square. I hope this is clear. So let's compare this. This is the displacement, velocity and acceleration with respect to their respective times. As you can see this, there is a phase difference. There is a phase difference of pi by 2. How do I understood that? Let's look at this. This is maximum at that point of time. This is minimum. When this is minimum, this is maximum, and so on. So there is a phase difference. There is a phase difference of pi by 2 between this two, and there is a phase difference between pi by 2 of this two. So ideally there is a phase difference between this two of pi. I hope this is clear. Is it clear? So this is the displacement versus time, this is the velocity versus time, and this is the acceleration versus time graph when particle has started its motion, from the extreme position. I hope this is clear. Is it clear? Is it? Great. So now let's look at certain quick questions. There is a phase difference of blank between displacement and acceleration. Yes, it's a pi radian. Next, the blank is maximum at extreme position. Yes. Displacement, because when you start from the extreme position, it is x equals to a cos omega t. Velocity would be the function of sine. It's an a omega sine omega t, but again it's a minus. And acceleration would be equals to minus of a omega square. It's a cos omega t. Yes. So displacement would be maximum, and the acceleration too would be the maximum at extreme position. So this would be the answer of this question. Next, the blank is minimum. At extreme position. Yes, velocity is minimum, because as we have seen in the previous slide, that it is the function of sine, and function of sine is minimum at the extreme position. I hope this is clear. Is it? Do you understand this? Yes, this all were the graphs for the velocity, acceleration, or displacement with respect to time. We have other few relations too of velocity and acceleration that we have learned in the lecture number 2. So let's first look at those relations, and then we will switch to the graphs based on them. So let's begin with them. We have this relation that x is equals to a sine omega t, or I should say v is equals to a omega cos omega t, or let's say a is equals to minus of a omega square sine omega t. These are the relations. These are the relation when we start our motion from the mean position, and this was the situation. Now let's suppose if we want to plot the graph based on the displacement positions, how do we do this? What can we do this? So before we plot the before we plot the graph, I know the relations of this functions with respect to positions. So x, it is the a sine omega t. For the v, we have this kind of relation: v is equals to omega under root of a square minus of x square. And a, it is the acceleration, which is equals to a is equals to minus of omega square x. So let's just first I will try to plot this graph. It's a v versus x. Let's have a look. We have the relation which is equals to v is equals to omega root of a square minus of x square. So if I square this on both the sides, it's a v square is equals to omega square into a square minus of x square. This can be written as v square is equals to omega square a square minus of omega square x square. From this, it's a v square plus omega square x square is equals to omega square a square. If I divide this with omega square s square, it's a v square divided by omega square a square plus omega square x square divided by omega square a square. This is equals to 1. If such is the situation, this omega square has been gone, and this is v square by omega square a square plus x square divided by a square. This is equals to 1. So this is the situation. I hope this is clear. So if you go through this situation, very carefully, you might get an idea that if I want to plot this relation for the, let's suppose on this axis velocity, on this axis x, then this relation would be of which trajectory? What do you think? Do you have any idea for this, that this is of circle, or let's say ellipse, or let's say straight line, or whether it could be a parabola, hyperbola? What does it represents? Do you have any idea? No? So let me make you understood that first. If we have a circle, then its relation would be x square plus y square is equals to r square. And this is such because it's an x square by r square plus y square by r square is equals to 1. So if you took this as a standard relation, x square by a square plus y square by b square is equals to 1, and for circle, this a is equals to b is equals to r. That is what we understand. Now we have a different relation for the ellipse. I'm talking about the general relation for the ellipse. This x square by a square plus y square by b square is equals to 1, and for ellipse, this a and b are not equal. This is a not equals to b. I hope this is clear. So this is ellipse, and when this is the case of the ellipse, then this is, look at this, this is v has been divided. That means v square has been divided by a square omega square, and this x square has been divided by a square. So it may represent like this. I hope this is clear. And the extreme value on the x-axis is the a, definitely on both the sides, and extreme value on the v this represents the a omega. Please keep this in mind. I hope this is clear. Is it clear? Is it? Are you sure? So do you understand this is ellipse? Is it? Great. So this is the graph. This is the graph for the velocity versus displacement. Now let's plot it. We have written the relation. It's an a is equals to minus of omega square x. And if it is a is equals to minus of omega square x, if I want to plot this, that let's say this is a, this is x, then basically this will represent a straight line, but their slope would be a negative. So if I want to plot this, it is something like this. Yes, it will pass through the origin, but as you can see, this theta is in clockwise direction. That means it represents the negative x, a negative value. I hope this is clear. Same way, if I want to plot the graph for the acceleration versus velocity, then this graph will give me such as this is the situation that this is the acceleration and this is the velocity, and the relation for this two could be written as this is v square by a square omega square plus a square divide by, it's an a square divided by a square omega to the power 4 is equals to 1. I hope this is clear. Yes, is it clear? Great. So if I plot this, it maybe look like this, and the maximum value on the velocity axis, it's an a omega, and maximum value on the acceleration axis, it's an a omega square value. I hope you got this. Have you? Have you got this? Please note this. Please notate this, and we will be having a question based on this. Very pretty questions can be asked from this, and this are having a very good value. So have you noted this? Have you? Do you understand this? Are you sure? Now let's switch to the question. Let's suppose I have given the graph of this is velocity, this is x, and the graph is given like this, that this value is 10 and this value is, let's say, 5. They have asked us that find out time period of a particle performing SHM whose v versus x is given. So we need to find out this. How will we do this? What could be done? What could be done? Yes, this v versus x has been given. So now from the previous graphs, now I understand that this is the a omega and this is the maximum on the x-axis, it's an a. So if I compare this two value, I can have an idea that this is a omega which is equals to 5 and this is a which is having equals to 10. If I took a ratio of this two, this is a omega by a which is equals to 5 by 10, and from this this as has been gone, so this omega is equals to 1 by 2, or from this it's a 2 pi by t which is equals to 1 by 2, and this t is equals to 4 pi seconds. This is the situation. I hope this is clear. Does it clear? Are you sure? Are you sure? Great. So like to have one more question based on this concepts. Let's have a look. The next question is that we have certain graph for the velocity versus acceleration. This is acceleration, this is velocity, and the graph is looking like this. Sorry, Yes, the graph is looking like this. On this axis they have given this value as a 20 and this value as, let's say, 10. They want to find out frequency of SHM. They want the frequency of an SHM. How shall we do this? What do you think? What could be done to find out the frequency of this SHM? So we have the relations, and according to this relation, this A is equals to A omega square, and this V, this is equals to A omega. So basically it's an A omega square which is equals to 10, and this A omega which is equals to 20. From this, if I took a ratio, it's an A omega square divided by A omega, which is equals to 10 by 20. This has gone, this has gone, this gone. So it's basically omega, which is equals to 10 by 20, which is equals to 1 by 2, and this is 2 pi f is equals to 1 by 2. So this f is equals to 1 by 4 pi hertz. I hope this is clear. Is it? Do you understand this? Do you? Are you sure? Do you have any doubts? Is there anything? No? Great. So let's wind up the session over here. This was the all about the graphical representation of SHM. Please revise this session very carefully, because this is not going to help at on SHM only. This is going to help in the waves as well as we have one more unit that is based on sinusoidal waves, that is the alternating current in the class 12. So this is basically the sinusoidal waves. When we say it's a sinusoidal, that means they belongs to a sine wave and cos wave, and they have a certain properties which cannot be exhibited by the different or by the remaining trigonometric functions. That's why we have a different segment, that is what we call as a sinusoidal. So please go through this, very interesting and very high probability to be asked in examination. Thank you. Have a good day. Take care.